All right, welcome to today's lesson. This is 3-3, solving two-step equations. Our objectives today say I will be able to solve an equation involving two steps using inverse operations, and I'll be able to check my solution. Our vocabulary words are inverse operation and properties of equality. You can find these in your vocabulary document on Schoology, but a quick reminder, inverse operation means how would we undo that step? So the opposite of adding is subtracting. The opposite of multiplying is dividing. How would we undo the step? Let's start with our building background. It says, Ferranda is in a super duper bad mood. She is currently with her teacher, Ms. J, and her best friend, Jade. If she wants some alone time, how might she go about it? So we need to figure out how to get her alone. She's with two other people, her teacher and her best friend. So remember, she probably wants to hang out with her bestie for as long as she can. So we're going to start by working out with her teacher, okay? Because she'll want to stick around her best friend for a little while longer. So if we want to work out, our first step might be to leave Miss J's classroom. Then she's still with her best friend. She does want to be alone, so eventually she's going to ask her best friend to leave her alone for a while. Okay, now she's all alone, and that's what she needed, some alone time. So let's think about how this idea could relate to order of operations and their inverse and undoing these steps. In order to be alone, she needed to remove people from her life for a little bit. When we're thinking about a variable, in order to get the variable alone, we need to remove numbers. So in order to isolate the variable, remember that means all alone, we need to remove the numbers around it one by one. And we want to hang on to that bestie for as long as possible. So we're kind of going to be working from the outside in. Remember, this is a lot of writing, so if you need to pause here and copy this down, go ahead and pause your video. Then we're going to be moving on to the examples. So our first example gives us the problem. All right, so number 1 says solve the equation 2x minus 7 equals 23. So when I look over at our process, these are going to tell us our steps right away. My first step is to highlight the variable that I want to isolate. Remember, isolate means get alone. So I'm going to write 2x minus 7 in the work spot equals 23. And I'm first going to highlight this variable, which is x. That tells me what I want to try to get alone. But remember, I'm going to work on my steps one at a time. So first, if I draw my line down the middle, I can see that whatever's over here on the left-hand side has to equal 23. I'm going to start by undoing this minus 7, and I'm going to think of it as adding the opposite. So if I have plus negative 7, I want to undo that negative 7 by adding a positive 7. Now on this side, negative 7 plus 7 is 0. It's gone. So now over here I have 2x equals 23, but it's 23 plus 7. So I know 23 plus 7 is 30. And next I need to undo the 2. That's the one next to the variable. So that is multiplying when they're right next to each other. So to undo timesing by 2, I'm going to divide by 2. Now my x is alone, so I have 30 divided by 2. That answer is 15. I want to check, my last step is to check and make sure that's right. To do that, all I need to do is rewrite my problem, but instead of the variable, I'm going to put my answer. So it would look like 2 times 15 plus negative 7 equals 23. Then I can use my order of operations to see if that works out. And 23 equals 23, so I know that's correct. All right, number 2. Our first step, remember, is to highlight the variable. So I see this y here. This is my variable. So when I rewrite my problem, I'm going to be thinking, how can I get this y by itself? So I have negative 4y plus 18 equals 46. My variable is y, so I'm going to think, how can I get this alone? I'm going to start by working with what's farthest away from y. I'm going to work from the outside in. This 4 is the bestie of the y. It's going to stay close for a while. So the first thing I need to do is undo adding 18 by subtracting 18. So I'm going to subtract 18 from both sides. And then I'm left with my negative 4y over here and 28 over here. Okay. My next step now is to get my variable alone. So I have to undo this times negative 4 by dividing by negative 4. So I'm going to divide by negative 4 here and divide by negative 4 here. Negative 4 divided by negative 4 is gone, so I have y alone here. And over here I have 28 divided by negative 4. So a positive divided by a negative. I know right away my answer is going to be negative. Here I have 7, so it's negative 7. Now if I want to check my work, what I'm going to do is copy this problem, but instead of the y, I'm going to put negative 7 and see if that works out. So I have negative 4 times negative 7 plus 18 minus 46. So negative 4 times negative 7 is 28 plus 18 equals 46. Does 28 plus 18 equal 46? It does, so I know that my answer is correct. All right, go to the back side. We're going to do 2 more examples. Number 3, we need to solve the equation negative 13 equals 5 minus 6x. So I'm going to write my problem, negative 13 equals 5 minus 6x. And I'm going to highlight my variable. You might notice that this looks different from the others. We have the variable on the right-hand side instead of the left-hand side. And that's okay. We're going to do it the same way we did. So I'm going to draw my line down the middle. And when I look at this problem, I see that I have to undo my first thing. And I want to keep that 6 next to the x for a little while longer. So I'm going to start with this 5. So to undo 5, I need to subtract 5. Okay? Right away, I'm going to start by changing this subtracting to adding the opposite. That will be a lot easier for me when I start working with that problem. So to undo 5, I need to subtract 5. So from this side, I'm going to subtract 5, and from this side, I'm going to subtract 5. Over here now, I'm left with this negative 6x, and over here I have negative 13 minus 5. Negative 13 minus 5 is negative 18. And my next step will be to get rid of this negative 6. So to undo times negative 6, I'm going to divide by negative 6 on both sides. So here I'm left with my variable x. Negative 18 divided by negative 6 gives me 3. I know it's positive because a negative divided by a negative is always positive. Let's check our work and see if we're right. So we're going to write out negative 13 equals 5 plus negative 6 times 3. Negative 6 times 3 is negative 18. Carry down the rest of my problem. And I can see that negative 13 equals negative 13, so I know I'm correct. All right, our last example says solve this equation, and you might notice right away this looks a little different. Remember, this fraction line means divide. So I have x plus 6 divided by 9 equals negative 4. Okay, I'm going to highlight my variable here. And the first thing I want to do in this problem is get rid of this divided by 9. These two are kind of together up on top. They're going to stick together for a little while longer. We're going to get rid of this bottom one. So to undo dividing by 9, we're going to multiply by 9. So I'm going to times by 9 over here, times by 9 over here. Okay? So now I have x plus 6 equals negative 36. Now I want to get rid of this plus 6. To do that, I'm going to subtract 6 from both sides. Now my x is alone. X equals negative 42. And let's check our work to see. If I do negative 42 plus 6 divided by 9, do I get negative 4? So the first thing I'm going to do is figure out what's this negative 42 plus 6. That equals 36. So negative 36. So if I take negative 36 divided by 9, I'm sorry guys, it should be at 4. Do I get negative 4? And I do. Okay. All right, your job right now is to write your summary. So you should have an answer here. If we come around and look at your binder, we should see an answer for this summary. How did you solve equations today? You can look at the steps and write them in your own words, or you can explain something from the building background.